Hello and welcome back to Stats Coach. Today's video is going to be an explanation of how to use and how to perform Fisher's LSD. So Fisher's LSD is used in conjunction with ANOVA. Remember that ANOVA only tells us if at least two of the groups are different from each other. So ANOVA is usually testing three or more groups in terms of a data set against each other to see if the groups are similar or different. And you will either reject or fail to reject. But if you reject an ANOVA, meaning that at least one of them is different or two of them are different from each other, you don't know which one necessarily is the one that is different. Fisher's LSD tests two specific groups against each other, and if we test all of the groups against one another, then we can kind of aggregate those results and determine which one or multiple of the groups might be different. The equation for LSD is equal to a T critical value multiplied by the square root of the quantity MSE times the quantity 1 over n sub I plus 1 over n sub j. So the T critical value also is found using the degrees of freedom within in the ANOVA analysis, as well as alpha over 2. LSD will be compared to the absolute value of the difference between the average of the first group and the average of the second group. So to determine whether or not the groups are different, you compare the absolute value of the average of group 1 to the average of group 2, and you reject if the absolute value of the averages is greater than LSD. So that is a short introduction into what I'm going to be showing now in Excel. All right, so now we're in Excel, and as you can see, I've posted the equation for LSD here within the Excel table. The little underscores are the subscripts, so T sub alpha over 2 and 1 over n sub I plus 1 over n sub j. But here we have this data set that we've used before. There's 3 farms. They each produce exactly 100 potatoes. And then the potatoes are weighed and the weights are shown here. So we're going to determine which farm is different. First, though, we need to determine if any of them are different. The way we do that is we go to Data, Data Analysis, and we run an ANOVA single factor analysis. I've already highlighted this, so this is already the correct input range. And then I'm going to output it here in E7. So here, when we compare our F statistic, since it's larger than our F critical value, we reject. We also know that we reject based on the fact that our p-value is smaller than our alpha of 0.05. But rejecting here means that one of these farms is different from the others, or potentially all 3 of the farms are different from each other. So Fisher's LSD, remember we have to calculate LSD, and we also calculate the absolute value of the difference of the averages. So let's do this over here. Let's take one column where we calculate the absolute value of difference of averages. And over here we do our LSD. This will make a little bit more sense in just a second. So here we're going to compare groups 1 and 2. Here we compare groups 1 and 3. And here we compare groups, 2 and 3. When we compare these 3 combinations, that will be comparing all of the groups, typo here, all the groups against one another. So first is the easy part. We just do the absolute value of the difference of the averages. So we're comparing group 1 to the average of group 2. We just do this down the line, absolute value of group 1 and group 3, and the absolute value of the difference between group 2 and group 3. Okay, so now we have to find LSD, and then we can compare that to our averages. I like to break this up into 2 different steps just to make it a little bit more simple. So first let's find this T critical value of alpha over 2. So I'll just put T critical. This is going to be the same for all of them, so we only have to find it once. So T equals T dot INV. we're going to use 0.975 because it's alpha over 2. Remember, right now, our alpha is 0.05. So alpha over 2 is 0.025. And then 1 minus that alpha over 2 gives us our probability, 0.975. For the degrees of freedom, remember in the slide, I said use degrees of freedom for within. So within degrees of freedom. All right, and then we can close our parenthesis, and we get a t critical value of 1.97 if we round. So now let's complete the LSD calculation. We do our t critical value times the square root of MSE, which is right here. This is multiplied by, and then I'm going to do another parenthesis, and then another parenthesis. 1 over n sub I is the size of the first group. Well, in this case, the first group is group 1, so the count of group 1 is 100. Then we're going to add, and I'm going to open another parenthesis, 1 over the size of group 2. Okay? And close that parenthesis, and then close our square root. It's supposed to be divide. All right, so our LSD for 1 and 2 is 0.1246. Here, though, our LSD for all of these values is going to be the 0.1246. Why? Because nothing is changing. Our alpha over 2 is staying the same for all of them. Our MSE stays for all of them. And then each of the sizes of the farms is equal. Each of them is producing exactly 100 potatoes. So when we do 1 over n sub I and 1 over n sub j, really you could just do 2 over n sub anything. You could just do 2 over the size of any of them because it's all going to be 1 over the same thing. So this makes our lives much easier when they have equal lengths. Now we just have to compare the absolute value of the difference of averages to the LSD, and we get our answer. So if LSD is smaller than the absolute value of the difference of averages, then we reject. So in this case, we reject. In this case, we fail to reject. And in this case, we reject. So again, all I'm doing is comparing this to this, this to this, and that to that. If either of these is larger, then we reject. So here, we're rejecting on 1 and 2 and 2 and 3. So 1 and 2 and 2 and 3 are different, but 1 and 3 are the same, or we have no evidence to suggest that they're different. So the common denominator here is that group 2, is different. We can also see that looking over here. 1.7 and 1.67 are very, very similar, but 1.141 is much smaller. So that's how we can determine, just kind of looking at it, it passes the eye check here, if you will. Farm 2 is producing smaller potatoes, and according to LSD, it's producing the different out of the 3 groups. So that is if they are equal lengths. If they're unequal lengths, though, the story is a little bit different. Okay, so here we have unequal lengths. Again, I have copied over the Fisher's LSD equation. But first, let's run an ANOVA analysis. This data set, we have 3 different boats. Each of the boats is catching a certain number of fish. In this case, boat 1 caught 30 fish, boat 2 caught 40 fish, and boat 3 caught 50 fish. So let's see if the boats are catching the same size of fish, or potentially maybe one of the boats is using a different bait and is catching either better or worse fish based on size. But first, let's run our ANOVA and see what the case is. So highlight over and then down. Oops. Okay. And we can output, let's do E7 again. All right. So here is our ANOVA output. So based on this, we have an F statistic that is 11.67, an F critical value of 3.074. So we are going to reject again, which means at least one of these is different from the other. Potentially, they're all different. So let's find out. Let's make our absolute value of average differences, and then our LSD column again, right? So we're going to compare boat 1 and 2, boat 1 and 3, and boat 2 and 3. Okay, and then let's find the difference, the absolute value of the difference between 1 and 2, between 1 and 3, and between 2 and 3. All right. Now we have to find our LSD value, and we're going to have to calculate this 3 different times because the n sub I, the n sub j, those are all going to be different now because the counts are different for each of the groups. But the t critical value is always the same, so we can calculate this again up here. Again, that's t.inv. We're using 0.975 again because our alpha over 2 is 0.025, and the degrees of freedom is still going to be within group. So this is our t critical value. We can now use that t critical, let me zoom this in a little bit. So we can now use this t critical value to calculate LSD. So this t critical value times the square root of MSE times, and then open parenthesis and open parenthesis again, 1 over 30 plus, open parenthesis, 1 over 40. And the way I'm getting 1 over 30 and 1 over 40 is group 1 is 30, group 2 is 40. So this is our LSD for this particular group comparison. We can copy this equation and put it right down here. And I'll do it again for this one. And now we have to compare group 1 and 3. So 1 is still 30, but 3 is 50. So we can change this 40 to 50. We get a new LSD value. And do the same thing here. We're comparing 2 and 3. And 2 is 40, so we can leave 40 there. And 3 is 50, so we'll change the 50 here. And again, it doesn't matter which order you do this as long as the numbers are correct. Right? Okay, so now we have 3 different LSD values. So we compare this to the absolute value of average differences. Here, since LSD is smaller, we are going to reject. Here, since LSD is larger, we fail to reject. And here, LSD is smaller, so we reject. So once again, it looks like the second group, which in this case was boat 2, earlier it was farm 2, is different from the others. And if we look at the averages, we see that that holds true. So the average for boat 1 is close to 5, the average for boat 3 is close to 5, so they're catching about 5-pound fish. But the average for boat 2 is 5.75. So if boat 2 is fishing in a different location or potentially using a different kind of bait, whatever their technique is, boat 1 and boat 3 should try to emulate that to catch larger fish, if that's the goal. But that is the difference between using Fisher's LSD when you have equal lengths or unequal lengths. If you found this video helpful, I would really appreciate a comment down below and a like, and also comment down below if you have any further questions on Fisher's LSD. I'd be happy to answer them. Thank you so much.